Hello. Hello, everyone. My name is Connor. I work at Eventual, and today I'll be talking about how we support S3 tables in Daft. A little background on myself. I live in Seattle. Is anyone here from Seattle or visiting from Seattle? Welcome, welcome. We might have been on the same flight. So in Seattle, I'm really into cycling, climbing, mountain biking, pretty much all the mountain sports. Super nice out there. And what brought me out there was Amazon. I graduated in 2019. I joined Amazon. I worked for CloudWatch Logs for several years. If any of you guys use Logs Insights, so yeah, it's a good service. So I worked on that for a few years, and then I worked on the particle query language. That's like a SQL dialect that's used on Redshift. It's used on QLDB, DynamoDB, and other AWS services. And that led me to Eventual, where I work on Daft SQL, and recently I've been working on our catalog integrations. And yeah, so pretty much when it comes to the catalog integration stuff, like Daft has really, really good I/O for tables. You can like read and write a lot of these open table formats. And so by building these catalog integrations, we're able to have higher level abstractions over that data frame I/O, and it kind of unlocks a lot of possibilities with our APIs. The basic agenda of this talk is going to be, you mind turning it down just a teeny bit? Thanks. So the basic agenda of this talk is I'm going to say like what is or like are S3 tables and like what problems do they solve, go over some examples of like why they're useful, and then we'll figure out how do S3 tables relate to Iceberg tables. Then I'll show you like how to set things up and how we can actually start using them, and then how you can use them with Daft. I'll demonstrate how to like read and write these tables with Daft. And with the setup and the AWS getting started, we're going to run into some problems, and so we'll like work through those together. And then at the end, I'll show like what's next for Daft and S3 tables, because we'll see there's things that we're going to be able to do that we know about that we can improve upon in our upcoming releases. So the first thing is, what is our S3 tables? So yeah, and why am I saying is R? Because there's more to this, so like we're going to dig into it. So first, S3 tables is a new AWS service. We'll see in the SDK, S3 tables is a different service than S3. It's its own thing. And it's offered alongside S3 storage. When you create a bucket, you can create a table bucket. And these table buckets are optimized for storing Iceberg tables, which is pretty nice. Check a box and you get better hardware for you. And then S3 tables supports Apache Iceberg tables. And there's something we need to dive into here. So we'll talk about like what exactly is meant by supporting Iceberg tables and supporting Iceberg in general. And then a very important thing is S3 tables is a service with its own API, but this API is not the Iceberg REST protocol. And we'll talk about what problems that has, but what we can do and how we can integrate with other AWS services like Late Formation and Glue, and we can make it Iceberg REST compatible. So what does S3 tables solve for us? Well, first, it reduces a lot of complexity, because you can just, the click of a button, create a bucket, and you already have like a hosted catalog service, you have your storage, you have access management with IAM. There's a lot of things that it does for you, and like all you're doing is just creating a bucket. So it's really useful. The other thing is it has like managed maintenance jobs. So you can just like, one API, put bucket maintenance job, and you have automatic compaction. You don't have to set up your own infrastructure. It's just all through S3 tables. And then S3 tables is decoupled from the table format. It sounds strange because like I'm only talking about Iceberg. It's just Iceberg, Iceberg, Iceberg. But you'll see like in the API, there's room so that like, say Iceberg were to like evolve to a new version and there's some performance improvements or some kind of setup that's better for your workloads, through these like managed jobs, you could be able to migrate to that new thing without ever changing your stack, because the bytes are just rewritten for you underneath. And then finally, these S3 tables make it really easy to integrate with other AWS services. So check a few boxes, and you can use Redshift, you can use Athena, you can write some particle queries. Okay, so how do S3 tables relate to Iceberg tables? We can think of an S3 table as like a logical construct. It's decoupled from the actual bytes. So like S3 table is just a name that we assign to a bunch of data stored somewhere. But then if we peek inside, we'll see it's just an Iceberg table. And so Apache Iceberg is the actual like physical format of all like the files and bytes inside of this bucket. And since S3 tables use Iceberg as the actual storage format, we should be able to just like read it with all of our existing tools without too much work. So let's look at our favorite tool, Daft. If no one here is, or if you are not familiar with Daft, it's an engine for data engineering, analytics, and ML AI. I think what's really cool about Daft is it has a Python data frames API, which is like quite ergonomic and really nice, easy to use, but also has a SQL API. And so depending on like your interest, background, whatever you like, or your current setup, you can use both, you can take advantage of it. That's also pretty cool because it runs lightweight locally and like can often outperform DuckDB, but it also seamlessly can run on a distributed cluster and integrates well with Ray. So it's a super cool engine, but can it read S3 tables? So, like I was saying, Daft has very good I/O capabilities when it comes to Iceberg. So the short answer is yes, we can read S3 tables, but how do we do that? What we need to do is map that logical construct of an S3 table to the actual Iceberg files. So here I have my setup, and this is the S3 table service, and there's the Daft engine. When I get some identifier, like select star from my table, I need to go look up, like, where is my table? What is it? And so a catalog is the service that tells us, given this path, here are the bytes for it. For Iceberg, that means go find this metadata file. Go find the most recent metadata file. Once you've given your identifier, you get back your metadata file, and that has all of the details of how to go find a bunch of S3 objects and start crunching. Okay, so we should be able to read them if we can get our hands on this metadata file. But I need to set some stuff up first. So now I'm gonna walk through AWS's like getting started tutorial, and we'll figure out how to like create one of these buckets, create a table, and our goal here is to upload a Parquet file. So the first thing is we go to the CLI and we see AWS S3 tables, create table bucket. This is a new service. You have to update your CLI, and it's not under S3. Next thing is we create a namespace. So when you guys work with Iceberg, once you have a catalog or once you have a place to put the data, then you have to create a namespace, and then you get your table in there. So I just created a namespace. It's just called demo. And now we're ready to create a table. To create a table, I have to give it the table bucket ARN, so the table bucket I just made. I have to give it that namespace demo, and then I'm naming my table points, and the format is Iceberg. So like maybe one day that'll say Iceberg 3 or Iceberg 4, or maybe it might say something else. But you specify the format because it might be stored as something different. And then I give it an Iceberg schema. For this one, sorry guys in the back, but there's 3 fields, X, Y, and Z. We have a Boolean, we have a number, and we have a string. We can do anything with those. So let's try to insert a Parquet file. So I go back to the CLI and I go AWS S3 tables, and do insert into, give it my table ARN, and I give it my file. It's like super easy. But of course this does not work. It's because I wrote insert. I should write put. Everyone knows that's the AWS verb. It's not insert. Insert SQL. No, I'm just teasing. So if we go to the APIs, we'll go look at put, and we'll see none of these APIs have anything to do with actually like putting data into that table. It's all managing metadata. It's all deleting things, creating things, namespaces, putting policies. So there's no API to insert data. So I keep going through the tutorial, and I'm like, okay, how am I supposed to do this? And then it just like jumps to this, and it's a Spark, like it's a Scala REPL with Spark, and everything's already all configured. And I'm following along, and it just says like we can access and populate the table in many different ways. For testing purposes, we've installed Apache Spark, then invoke the Spark shell with, quote, command line arguments. But I'm like, what command line arguments? Like, it's pretty, I just want to upload my file. Getting to this point is not trivial. Yeah, so one does not simply just install Spark and invoke it. It doesn't work that easily. So yes, we're gonna figure out what these mysterious command line arguments are. So I went to ChatGPT. So I found a different, I went to a different blog post, and what I saw were all these arguments. So it's just a bunch of configuration, and you'll see these like probably Maven path stuff, and it's pointing us to this like jar that has a bunch of logic to be able to fetch this metadata and so on and so forth. And when I tried to follow this tutorial, I had some issues where I just kept getting like class not found, and add another dependency and go class not found, and you're like, if you depend on that jar, why aren't you pulling it transitively? But whatever, it took me too long. Someone smarter than me will figure it out. But another thing I noticed is the bucket that I created was like called pond, but here it's called like Spark catalog. So when I first got this thing running, I was like trying to like say, catalog.schema.table, and it like renamed my catalog. I was kind of confused by that, and then I realized I don't think I can connect to multiple S3 buckets if they're all just going to be named Spark catalog. So I figured there was some room for improvement here. And also, what about Python? A lot of us use Python, and I didn't really want to be dealing with all these jar issues, and I'm just trying to upload a file, so we'll figure out what we can do. Yeah, I just created all of these resources, and I still can't upload stuff. So now what? So we're going to explore some alternatives. And this was cool. This is in like one of the benefits of S3 tables is check a few boxes, integrate with all the different AWS services. But I don't really want to start using Athena and Redshift, and I don't want to incur like additional dependencies, additional costs to upload a file. That's all I'm trying to do. So then let's go look at Daft. So to get started with Daft, we create a new Python environment and do pip install get Daft. It will pull in its dependencies for you. So to connect to S3 tables, we can use Daft's new catalog API, and this is something we just released. And we have a method where we import the catalog, and then we say catalog from ARN. And I give it the ARN of my table bucket, and that will give me back a Daft catalog object. And with this, I can start doing what I need to do. So I say my S3 table, call out get table, pass in my identifier, and now I have a Daft table. I call .show, and this is what it prints back out. It's empty, but that schema looks correct. I have my X, my Y, my Z, my Boolean, my number, and my string. So this looks good, but how did we get here? How were we able to read this? Going back, we have the S3 bucket with the Iceberg under the hood, and then we have the Daft engine. And the first thing I do is I go find that metadata.json, and when I get it, I pull that file, and then I use Apache Iceberg, static table. Given that JSON, I can go find all the objects. That was pretty easy. Happy about that. I still need to upload my Parquet file. So with our tables, you can write to them. Like I said, Daft has the ability to write Iceberg. So just like you do with an Iceberg append, I go to do my Daft table. I append my Parquet file. If you give it a string, it knows that that thing's a file, and it knows that it's Parquet because of that extension. But this throws an error. It was not going to be that easy. And the error that we have here, sorry guys in the back, is a not implemented error. And it's not that it's not coming from Daft though, which is interesting. It's coming from coming from Pi Iceberg. And if we look closer, it's coming from the no-op catalog, and it failed on commit table. These are some new concepts, so let's try to dissect this. To step back, how do you actually write data in Apache Iceberg? Well, the first thing you do is, again, you get that latest metadata file. You need to know where everything is, and then you actually perform the operation that you want to do to then insert. You need to put all those new files. It's S3. It's append, don't, like you're just pushing stuff. So you put all those new files in there, and then you need to update and create the new metadata file, and then you need to tell everyone else that okay, here's the new source of truth. This is where you find stuff. We put more stuff. This is the new metadata file. This whole thing we call a transaction. And the catalog is responsible for handling this transaction. But we just had a no-op catalog, and it can't do transactions. And so this is why we get the not implemented error. So we were never actually using an Iceberg catalog. We just pulled the metadata file and just read all the objects, but we don't have, Iceberg's catalog to handle this stuff for us. So how do we get one? Well, we could use the Iceberg REST catalog. This can handle the transaction for us, but like I was saying, S3 tables is not Iceberg REST, but we can make it work with Iceberg REST. In order to do that, we have to check a few boxes. The first one is we need to integrate with Analytics Services Preview. This one's in S3. When you create your table bucket, you'll see at the top of the screen there's a huge banner that says Enable Integration. You need admin privileges, and you just click that box. Pretty good. And then you go over to Lake Formation, which is a new service, and you'll see this new section called Catalogs. And in there, you need to check some more boxes and create a glue catalog. And it's relatively easy. Honestly, like the biggest headache is permissions. So just doing everything with admin permissions. Set up Lake Formation, enable glue, Iceberg REST. And this is the new state of things. So rather than Daft talking directly to S3 tables, it goes to glue. And glue has Iceberg REST, and Daft speaks Iceberg REST, and we should be able to do transactions now. So let's revisit this example, but instead of going just to this table bucket, let's go through to Iceberg REST. We'll go ahead, import the catalog from Daft again, but we're also going to import PyIceberg, the PyIceberg load catalog function. And it's kind of hard to see, but we're loading up an Iceberg REST catalog, and we give it the glue URL to say, go connect to this Iceberg catalog service. And then instead of saying, create a Daft catalog from an ARN, we're going to say, create a Daft catalog from the Iceberg catalog. And do a sanity check. We use this one, and we call get table. We pass in our identifier, and we get back our thing. And lo and behold, it is still empty. So this right here is, I'm showing you that I got a little bit of data insert. I just used the Daft read parquet function. This will make a Daft data frame. And .show will just print it out. So we have 3 rows. And then I can call append. And it's okay this time. And then I do a points.show, and I see that my data's in there. I didn't have to call get table again. The PyIceberg handled the metadata refresh. It knew that I had written something. It knew that I had to go back through the catalog. It knew that I had to pick up the latest metadata file, and I got my data. But wait, there's more. So the catalog stuff is also integrated with our SQL API. So now when you have, say, a SQL session, you can attach this S3 tables catalog to your SQL session, and then just go ahead and write SQL. Select star from demo.points, show, that'll return a data frame, and you can see we can access all of this and write SQL statements over our S3 tables as well. And then here's what the whole thing looks like, and this has reads, writes, create namespaces, you name it, and all you gotta do is, import a couple things, and it's 4 functional lines of code. So looking forward, we're going to be releasing the support for S3 tables next week. But in the latest release that we just did this previous week, or earlier this week, we introduced these catalogs, tables, and sessions, so you guys can already start working with them, and you can work with the Iceberg one. And we support writes today using the Iceberg REST catalog. You just can use the data frame, write Iceberg, you pass in your PyIceberg table, and you can write stuff. And then we're on track to support Iceberg tables without AWS dependencies. So we have a path forward to be able to write using that from table bucket ARN. You don't have to configure Lake Formation, you don't have to configure glue. We'll actually be able to write to these things directly to the table bucket. And then we'll be presenting in more detail at the Iceberg Summit on April 8th. where we'll get into more details of the code and have some more complex or more detailed examples. And then we have a little time at the end now. I think I'm right at 20. We're hiring, as Chan Chen shared. These are some of the roles, and if any of this interests you, please scan the QR code and feel free to email us. Yeah, I got a couple minutes for questions.
Hello, hello. Cool. You, sir.
Thanks for a great talk. Can you actually go one slide back?
This one?
Yes. So supporting Iceberg without AWS dependencies. So I'm a little bit curious about that one, right? So what's going to be the catalog then, right?
Yes. So S3 Tables is like a catalog service. It's just not an Iceberg catalog. So so we can't just use PyIceberg backed by S3 Tables like API directly. We have to put that layer in between using Glue to make it speak the Iceberg REST protocol. So fortunately, S3 Tables does have all the APIs to perform that transaction. It does have an API to like put the latest metadata location. So what we'll do, and this is what I mean by we have like a path forward, is we perform our updates, we push our files, we make our new metadata file, we put that in the bucket, and then we call the S3 Tables update metadata location. And so now S3 Tables is the catalog. Yeah. And that's what I mean by no dependencies. You don't have to go configure multiple services now. It'll just work.
You're going to still call their API.
Of course, of course. Correct.
Not like no.
Oh yeah, I should have said without lake formation and, you know.
You said S3 table support fine-grained security. So, but how you support with S3 table row-based security and column-based security?
Yes. Yeah, no, that's a great question. That's what I worked on when I was at Amazon for like 6 years before this, and I actually worked on row level and column level security with views. It's really interesting. I don't know about that. I only know about like namespace and table level security. You can do it at the catalog level because you have multiple, and you can do it with the key prefixes and stuff using like IAM traditional stuff. Lake formation also has its own policy mechanism for access control, and that's on the like tables, namespaces, and catalogs. But when it comes to rows and it comes to columns, I think we'll have to wait and see what AWS possibly offers there.
Yeah, I think it would not be even possible because with S3 tables itself is just kind like a catalog, but the data is in regular bucket. In regular bucket is just a Parquet file, and there is no option to allow you to read part of Parquet file, but not the other part.
Yeah, exactly. We had to. There's more complex details on how we were actually able to accomplish row and column level security, but we had to do it by defining views, and you actually query those views, and so there is a layer of indirection over that. And like you were saying, well, if you just given them the bucket, then there's no indirection. So how are you going to keep the whatever rabbit in the hat?
Take one more. Where? Pillar?
Hi, yeah. So to my understanding, like you can technically write Iceberg tables on just general S3. Then S3 tables is like AWS's way to like optimize that and stuff. I never really looked into like if they made that information public, but I'm curious, like, is there any knowledge about how they've done that, and like in your experience, like how much of performance benefit does that make? Because I hear it's a heftier price tag.
Yeah, so it's $3 more per terabyte, which is honestly that's not too hefty. $3 per terabyte, but I don't know the details under the hood. Like I'm here, so I don't know the details under the hood. But I'm assuming if you know how the data is stored and you know what the workloads are, they're probably just choosing hardware and they're probably just optimizing that one path rather than just being like general object store. But
So question here, can somebody hear me? We can hear, right? So, so one of the things is when you have these catalogs, you need to have them distributed across regions because the catalog is the ultimate truth that happens. And when you have a bidirectional updates happening, the replication that goes across becomes very cost prohibitive. What S3 tables are doing is they're doing one way in one region to go down to the S3. S3 is 7-way replicated. So they need an interface layer in between, which is the real ground truth, and then push to S3. So have you actually explored solutions where people for disaster recovery have the catalogs in 2 regions, and that's the ultimate truth that where happens? Just I want to check your brain. I'm fairly comfortable with Delta Lake and replications across regions, so we can take it offline if you don't have an answer. You don't need to answer now.
Yeah, no, I don't have an answer. That's a good question. I didn't look into cross regions, just US West 2. So we're on PST. No, but that is a great question. We'll talk about it. That sounds interesting.